Hi, Jarrell, how are you? We'll start in a couple minutes. I'm gonna check out your notes and your assignment. Thank you. Good. Glad to hear you're doing well. Let me zoom in and I will share screen. Activate live transcript. Are you Lane? So let's check out your notes and your assignment on week 8. You can find that posted there, and then I'll have the video recording tonight. So we're going to work with Nmap this week using Python module. And some of you are familiar with Nmap or Zenmap, and we'll touch on how we can incorporate that with our script. Okay, so I'll go ahead and get started. I think more people will join us shortly, hopefully. So as we are looking at our notes for this week, we are going to work with your Nmap Scanner. And some of you are familiar with Nmap using Kali Linux, or if you're using the Windows, you might have downloaded Zenmap and be able to scan. This is going to allow us, this application allows us to scan for open ports, closed ports, filter ports, operating system, looking at hops. So mostly we want to really explore the ports, and that's part of discovering information. And we can also use it to run some of the scripts. So Nmap has scripting capability. And so we'll touch on a little bit more on how we would be able to incorporate this with your Linux operating system. So let me also start my Ubuntu machine. So as you look through the notes, it shows you that Nmap can work synchronously and asynchronously, and we'll come back to this aspect. Your network mapper is, which is what we call as Nmap. This is an open source tool. It works with cross-platform, so it works with Windows, Linux, and other systems. You can download Nmap from the link here. If you're using the GUI version, you can use Zenmap, and you can check out the requirement to be able to install that. So using Nmap, we are able to do different types of scan. We are able to scan using specific protocol, and also looking at the type of destination packets and so on. So let's come back to the assignment now, right? For the first question, it asks you what type of Nmap scan is used to determine the target's open port based on its response for the server ACK flag. If you look at the list on the notes, it tells you that ST is gonna ST with the TCP Connect scan. This is a type of scan that we can use with Nmap when we are looking at the response from the server for acknowledgement. When you're scanning like HTTP server or a specific type of server, you can use ST is a way to look at your open ports for that server using the app flag. So you can find this information on page 1. Okay. In the scan, it is going to look at what ports is open. It's going to look at what the server respond when it receives the SYN flag. So specifically, if you're using ST, it's going to refer to the AG and the SYN flag. For the server side, it will be the acknowledgement flag. Now, if you want to do a stealth scan, and on the GUI interface, you should be able to select that, but on the command line level, when you're using Kali Linux, you should be able to specify the type of scan that you want. So for the SS, that stands for stealth scan. And this is it's very close to what you see with the TCP Connect scan that we talked about previously, but it's using a different connection on the port that is not completely established. So it's going to check the packets when it's responding with the SYN. So the ST, it's going to look at the AG, acknowledgement flag. And for the SS, it's going to look for the SYN flag. And that's the main difference. If the target responds with an RST flag, that means that it's going to check for the port is open or closed. Now, depending on the type of scan, some scan when you're getting an RST flag, that just means that the port is closed. So we can choose the specific scan for our own purpose, right? Whatever that we're trying to achieve, or our target, what it needs. Now, if you're using an SU, it's only specific for UDP. So it is gonna allow you to determine the open or closed port based on ping message or ICMP message. So if it's able to reach the destination, then that port is open. If it's not able to reach the destination, if it's timing out or unreachable, then we know that that port is closed. So when you're doing an SU scan, you would see that it's going to ping the system. So that means that it's going to submit the ICMP message to the target system. Now, another scan that we also see is going to be SA, and this is going to give you firewall information. If the machine is running a firewall, you can use an SA or acknowledgement scan to determine if the firewall is there. On the remote machine, if it's responding with an RST flag, then the port is shown that it's not filtered by the firewall. But if it is responding with the ICMP message, then it would be sent to a specific port. So depending on what, if they're implementing the firewall, if the firewall is filtering, then we can see that it will be on a specified port. So the rules is set on the firewall. So you would see that it's going to respond with the ping message. On the SN scan or the null scan, this is used without any flag. So in the case that you don't know what kind of system it is, or the specific protocol that's used, you can also use the null scan or SN. This is going to generate a response if the ports are open, and if the ports are not open, you're going to get an RST flag. So that means it's closed. For the SF, this is going to be the FIN flag. And if the target responds very much like the null, then it means the port is open. And if it's responding with an RST flag, that means it's closed. So you can specify what you want as scan. Like I said before, we would determine that based on the target's need. And then lastly, your Xmas scan, that's going to be for the target with the flag push, fin, and urge for urgent. And so if the target generate any kind of response, we would know that the port is open. And if it sends you the RST flag, then that means the port is closed. So for the first few questions, we already answered number 1. For number 2, it asks you when you're using the SU or the UDP scan in Nmap, how can we determine if the target system has open or closed port? If it has an unreachable ICMP message, that means that the port is closed. If the UDP packet has the response, so if it's responding, if it's reachable, then that means the port is open. So it's simply ping the target system there. And you can also specify on Zenmap or Nmap how you want things to be run. And so we would test that with our Linux system in a little bit. For number 3, how can you determine if the port is open or closed using the SN or the null scan in the Nmap? So if it generates any kind of valid response, then you would have the port open or the target port is open. If the machine generates an RST flag, that means that the port is closed, and that's how we can determine. So null is very much like Xmas and the other scan. So when it's simply waiting for some kind of response. If it's getting a response, you have the port open. If it's generating an RST flag, then we know that the port is closed. Any question on this? Now, we want to dive into this because as you use it later on, you're going to see that we can check for a specific type of information outside of just scanning the ports by specifying the type of scan that we want and the options for that type of scan. So when you scan using Nmap, you are looking at open ports, closed ports, filtered, and unfiltered ports. And the main difference between the filtered and the unfiltered port state is that the filtered, you will have no packets that will be that were received by the state that could be established. So you don't have any kind of packets that will be received on the filtered. On the unfiltered, the packets would be received, but the connection or the state could not be established. So because we have to check beyond the closed and the open ports, we also want to look at whether the port is filtered or unfiltered, because in some network, you would have systems that would have ports that are filtered using application firewall, or it could be that they're using a specific appliance to be able to filter some of the ports. Or in some cases, we would have unfiltered ports where the packets would still be received as it's sent, but the state would not be fully established. Okay, so the main difference is that your state is not established here and the packets would be received. Any question with 4? Okay, so where can I find this information on the port state? That would be on the bottom of 1. And it talks about open, closed, filtered, and unfiltered, going into the top page of 2. Now, the notes expanded further, and it goes into using Nmap, which we often see it being used as a way to audit our security, to look at, do an inventory of your ports, what's open and closed for all the systems in the network. We can scan a range of systems. We can scan a specific target by specifying the IP address in our Nmap scan. We can also use it to do some intrusion detection or intrusion tests. And mostly this type of tool is used to discover ports. So from an attacker standpoint, Nmap is often used to look at what's available, what would be open ports and closed. Also, it would also give you the operating system information. Sometimes it would give you the details about that specific server or system. Now, the repository here is being managed for the python-nmap, which is a module that we can use in our Python script to implement Nmap. However, when you write a script to use Nmap, your application needs to exist. So that script would only be ran successfully if you have Nmap installed. So for example, if you run this on Kali and if your Nmap is already there as an application, it works. But if you're using a different Linux system like a Raspberry Pi or Ubuntu in my case, and Nmap doesn't exist, you have to install Nmap. Okay, so if you are trying to import an Nmap and look at its version, if you don't have it installed, it would not work. Okay, so that's what we're going to do next is we are going to attempt some of the installation and then how we would be able to use Nmap in your Debian Linux. So I have a typo here. Let me fix that. If you want to install Nmap, you can simply use pip3. Okay, and this is because it's a Python module. Now, if you do it on Windows, it should install fine. But some of the commands that you would see down the line, right, the book is written to be used with the Linux system or Debian Linux. So in the Debian Linux, we can also use pip3 install if you already have your setup tools already installed to allow pip command to be available. So here, let me log on. And then we will try to see. You can simply go to the terminal and then you would be able to access it. Now, can you run Nmap directly from Python shell? You can once you have installed the python-nmap module. You can use it as it would have the appropriate classes and objects to be able to allow you to access some of the properties. Open this up. So if we simply issue pip3 install and Python nmap, all you're doing here is you are bringing in the module that would work with Nmap using Python. You're not really installing the Nmap itself, right? Now, if you're using Kali, Nmap comes in Kali, but if you're using other system, you have to do sudo apt get install Nmap like this. Okay. And since I recently installed it on my Ubuntu Linux, it tells me that it's already met the requirements. Okay, it is the newest version. Now, if you have a dated version, you can simply push an update. But in order for your module to work, you have to be able to install Nmap. Any question? Okay, so for example 1, let's take a look at the example 1 before we run it. And I'm going to use Tawny. Oh, maybe not. Okay. So in example 1, and this is the example that's provided by the textbook, we would see here that once we have the Python nmap module installed, we can issue an import statement. And if you run line by line on shell, you should be able to get the entire program built, but you can also write the script. So to really start using Nmap, using the Nmap module, you would need to create an object. And for that object, it's going to use the superclass port scanner. This class is going to allow you to bring in a certain domain or system that you want to scan, or your target. It's also going to allow you to specify the range of your ports or a port that you can scan. So in this program that's provided by the author, he created an object called port scanner. And this object is instantiated using port scanner superclass, okay? And it's going to use Nmap from here that you imported. Now the user is going to put in either the IP address or the domain that we want to scan. So here we would then put in the target, and what it's going to do is going to plug that into the parameter of your port scanner here. Okay. Now, because we specify the host scan in the module, host scan is going to be plugging in the parameter for host. So when it scans that, it's going to look for the host, which could be IP address or a domain. Then we are going to specify the port list. So a way that we can also do this is when you're looking at the simple, let me move this real quick. If you're looking at a simple program, right? No, I don't want that. Let's see. Well, maybe I don't have it. You simply just use the scan method, and in the parameter of the scan method, you can just simply put your IP address in quotation mark or your URL, right? Your domain name. And then you would then specify your port range. And when we're using the option N and P here, this is going to give us the port, a group of ports that we specify in the port list. Okay. Now, when we want to print, we're going to bring down the object, which is our port scanner. And we're going to use the command line method because it's going to execute the command to tell Nmap, right, what to scan based on what we specify in its parameter. For your host list, we can specify how we want the host to how we want to scan the host. So here is where we would loop, and we want to look at your host status. So we would be able to print that out. So as it iterates through that. Now, depending on the type of scan, for most part, if we're using a synchronous scan, it's going to go from one port and then the next port and then the next port. So after it finished with the port 21, it's going to then scan 22, finish with that scan 23. Now, if you do asynchronous scan, it's going to scan all of the ports together, okay? Where it would use, it doesn't have to wait for each to finish in order to scan. So when you're doing a simple scan in Zenmap or Nmap, what you will see is you're actually performing the synchronous scan, which means it has to look for the port, scan it, finish, and then move on to the next. Whereas if you want it faster, you can specify, right, the type of ports or the number of ports that you want, and it would do that concurrently. So in this case, we're going to scan a group of ports, and then we're going to look at the protocols that's using these ports for services, because it's going to be able to give us more details in how in the result where we would output that. So let me see. And then we are going to go ahead and run. So after I have installed my Nmap and my my Python nmap module, I can write this file, right, by using nano. That will be AX1. Okay, so here's the program, then we can save, and then we can run it using Python 3. So here we would have to enter some kind of IP address or a domain. Now, if I want to use, let's say, the example from the text, if I want to use like, let me see, we can use scanme.org. Let's see if I try using. So if I scan myself, right, which I'm using a loopback address, it tells me that my system is actively running. My port 21 is closed. My port 22 is closed, and so on. So what it did there was that when you're using the simple scan, right, and we specify the type of ports, it's going to go through and it's going to look at these ports, okay? And then it tells me that these ports are closed. Any question? So coming back to what we were saying earlier, our script will only work if your Nmap application is installed. And in the Linux system, when you're using your terminal, you can install Nmap by doing sudo apt-get install nmap. You can also go and manually download it from the website and use Nmap if you want to use the GUI. So you would visit the URL that's provided and you would be able to click the proper download. And once you download, you can go through the installation. So with that said, we are going to attempt exercise 7. Okay. So in exercise 7, what I have you do is instead of writing a script, we can simply run everything through our command line, because sometimes if it's really short, we can just use our Python shell in command line in order to just run some of the commands. So the first thing that you need to do is you need to first install this. Okay. And you should also install python-nmap. I didn't write that step for you. Okay. So again, I'm going to go ahead and clear this. And I can do sudo apt-get install nmap. So I want to make sure that my application is installed. Then I should do a pip3 install python-nmap. We are using the module for Python, okay, which is python-nmap. And we can do a pip3. If you don't have pip, then you can install the setup tools. It will tell you you need to install the setup tools in order to install pip. Then after we satisfy that, we can start with looking at which directory. Okay, so we would need to enter Python now by using Python 3. So here it would take me to shell when I issue the Python 3. Okay, so for your exercise, make sure that we install Python nmap module by doing a pip 3 install Python nmap command. Then after that, we would use Python. So we call it Python by doing Python 3. Then next we would start using some of your commands. So we would do an import nmap in shell. We would create an object called port scanner, and then it's gonna be instantiated for port scanner class. Then we are going to look at which directory. Okay, so we're gonna do import nmap. Okay, so once you have everything installed and ready, it will tell you that we can use it. So we would say port scanner is, and that will be nmap dot port scanner, and it's case sensitive, so make sure that it's typed exactly the same. Okay, so you would create an object or instantiate the object. And then in the next step, after we create the object, we would issue the dir. We would use the dir method. Basically, it's going to give you a directory of where that scanner would be. And since we name it port scanner, we just need to bring that down. And it's going to give you the directory of where that would be stored. Okay. And at this point, after we use the dir, okay, method, we can just take a screenshot. Now, if you're getting some funky error, like it cannot find your port scanner object, or it cannot create it, it's because you're missing nmap, and you're also, if you're missing Python nmap. Any question? As it is a common tool, we want to be able to use it flexibly, right? We can install an application and be able to run it with the GUI, or we can use the Linux terminal to set it up. Now, if we want to start scanning, we can create a variable called results, and this is going to store, right, the outcome from the scan that we're going to do, and we're going to use the scanme.nmap.org. So this is a site, and we're going to scan port 80 to 85. So your range of port, you just have to put it in quotation mark. And then the type of scan that we're going to use is you're going to be, the V stands for the version. So we are going to look at the specific version from these range of ports. Okay. And we're going to print it out. So you can just result as a return. Let me copy and paste this so it's quicker. And it might take a few seconds for it to go. Okay, because it has to reach the site, and it's going to generate. Okay, now if we can simply do a print results here, and it's going to give you a lot of the details. It's going to say, okay, it uses the command nmap ox, right? And for the port, it will be option P. So at the command level, you would see that it's going to break it down. It's going to tell you these are the commands that it used. It's giving you some information, timestamp, how long it's going to take, what kind of host. So we have one host that's up, 0 hosts, that's down. The total host is only 1. Your scan, this is the IP that would tie to scanme.nmap.org. And then it, so in in the Zenmap, whatever that you would have on the interface as the report, you would also be able to see that here. Okay. And you can run it directly in Python, but Nmap as an application works with command line. So, and then you can get some details. Now, this can be a lot of different things, right? Where it's not organized, so you can format it a certain way, like with CSV. So you can eventually use, put that into a table or use some kind of format tools to organize your data that's output. Okay, so as you finish that with the scan for the range of port, take a screen capture. Any question regarding 7? Now, if I make it as a script, it would look like this. Okay, so I would have import nmap for the first line. I create an object for the next line. I can have it print out the directory. If I need to get help, I can also use the help option. So the textbook, it goes through and it shows you how the authors use it in the shell. So I wanted to create an exercise that you would be able to do that. So you can use Python shell directly, as long as you have the Nmap application and the module installed. And then we can have it print out the result. Okay. So in the second exercise, it is a longer program, but before that, it talks about synchronous mode and asynchronous mode. Okay. So in a synchronous mode, like what we mentioned before, our scan is done on one port, then it finishes this, and then it proceeds to the next one. So when you have a range of ports, depending on how large your range is, that will be the number of inputs, right? If it's many different ports, let's say I wanted to scan from port 2000 to port 6000, that will take a little longer as my input is high, compared to if I'm scanning port 2000 to port 2005, that could be quick because it was just going through one after the other, and so on. That will be synchronous. For the asynchronous, if you're scanning different ports, it could be a range or a group of ports. That's what you see in example 1. We can use a function to be able to execute that where the scan will finish for a specific port, or you can do them simultaneously. So when you do have a larger group of system that you need to scan, or the number of ports that you need to scan, Nmap allows you to do so using the asynchronous mode. That will be on page 3 of your notes. So for number 8, it asks you, what is the difference between the synchronous mode and asynchronous mode? So like we mentioned before, synchronous scan done in one port, finishes it and proceed to the next. Whereas asynchronous mode, the scan is done on different ports simultaneously. We can use a callback function to execute when the scan finishes it on specific port. So synchronous mode would be ideal if you have less number of ports to work with, or maybe only one single port, whereas asynchronous mode, you would have a larger range of ports to evaluate. Any question? Okay, So now let's come back here. So before we do the next few exercises, let's take a look at the example. So what if I want to organize my output and format it as CSV, where it can be used to, you know, look at your data a little cleaner and be able to export it to different type of system or applications and so on. Now, if you're doing the CSV format, we need to parse it. We need to make sure that we import CSV. Okay. And we would define a class called Nmap Scanner CSV. Okay. And then in that, we would create, right, your members, which are, here's the object. Okay. And it's instantiated as port scanner object. Then we would define a member method, which is a function that's going to execute under that class. And in that definition, we would do a try and accept. We would try. If it's successful, then it's going to give you the ports information as we would specify that here. So when you're using port scanner .scan, right, whatever that your host would be and your ports would be, that will be plugged into the parameter. Then we are going to execute the command. And so when you're using the command line method, okay, and this is what you saw in the prior example as well, this allows it to access the command line method from the module to execute the command at the command level. We're doing an asynchronous scan trigger the firewall scanning multiple ports at the same time. Yes. It would. So we would first need to evaluate. So let's say if you're trying to be stealth, then you need to do it in stealth, like what page 1 described, right? You can scan as with the stealth scan. You should also check the system if it has a firewall. But this is invasive either way, so it's gonna, because in order to see what ports is open and closed, we have to either ping it or send some kind of message to it using Nmap. So when you use Nmap, it needs to send and receive. And that means that it's gonna be, it's gonna send back to your system. So they will be able to see who's trying to evaluate the ports. Okay. So no matter what, right? Even when you use the stealth, it's still be able to detect it. But if you're just using a simple scan, it will trigger the firewall no matter what. Now, if the firewall is filtering, right, you would then have, it's gonna put it into a certain port. So you can look at that port and see, you know, so it will specify on your result whether it's a filter port, open ports, closed ports, and so on. So at the end of your objective for the CSV program, right, is to be able to print things out in CSV. So you see that here. So like we mentioned before, your command line method here is going to be used to issue the command. And we're going to use some of the command directly in your command line so you can see. Then we are going to print out host information. We're also going to use the with open statement to be able to access the file. And in order to generate this into a CSV file, you have to open the file, write to the file, right? And then be able to continue in that file with setting up the host, the protocol, the port state as roles. So you would make it more organized. So when you look at it, it makes sense. Then underneath that, we would have a for loop. And our for loop is going to be able to specify how your host, protocol, port state would look on specific lines. So here, all you're doing is to organize the output on the file in ways that it would be cleaner on the specific lines. And then we would print out our port state and protocol state because that would represent the services that the target is running, right? And then again, we would do a write role to that CSV file. Then that would be the try section. Your except statement, we would just gonna handle the error and then print out that it's gonna have a hard time, because if it's timing out, it's not able to scan, then we can print out the exception. Then we have another function called main. And here we would use the op parse, and this is why we import it at the top. And this is going to be a parser, so it's going to parse things that will be comma separated, because CSV, that's what it stands for. That's a type of file. Because without this, it will not be able to extract pieces of data that's coming from your result of the scan. So we want to be able to parse that. Okay. And so now when you're making the CSV file, you would use the Nmap Scanner CSV, which is what we had stated at the top. But the actual scan.csv, we would use the parameter host ports. So where is that coming from? If you look up here, I went too far there. We defined a function earlier, which is a custom function that we create here, right? But that function needs to work with the module method, or the function that comes with the module, and which is Nmap Scan CSV. So we simply call on that functions, right? And be able to use the module method. And then because this is part of your main that you define, you simply call main in main namespace. And that's how you're able to write with CSV. And with CSV, it would be good for, data analysis, where if you have it set up as a CSV file, you can use it to, even in Python, you can use it to read, you can use it to organize your data, you can use it to graph with NumPy, you can use a lot of different things with Python tool to do data analysis. Okay, so CSV files are great. So here it tells you that we are using CSV. We set up each of the line to contain host, protocol, port state, and information in the file. Now, if you're familiar with Nmap, you would also see that it can be used to scan for OSs. The reason why we would do this is we want to look for vulnerabilities. And in some operating system, as it would be a software, right? The version of the operating system would tell us indicate some common vulnerabilities. For example, Windows 10, right? Or even, Ubuntu earlier versions and so on. In order to write this, we would need to use the sys. So anytime that you're dealing with operating system, you have to use OS or sys module, like what we talked about weeks ago. So in this one, we would need to import Nmap and sys. And with operating system, we would use the variable command, and that will be, it's going to call on the OS detection.py, and it's going to plug in your host name and IP address. So that will be your target. Then we are going to use sys.argv, okay, to be able to print. And then we would do a sys.exit method to exit. We've seen this before when we talked about sys module. Now for your host, again, we define our host with the sys.argv. Remember that when we're using sys module, right, that's going to give you access to platform. Then we are going to create a scan object. So when you do that here, you can name it anything you want here, but as long as you specify that it's instantiated for the port scanner class, which is a super class in that module, in python-nmap module. Then we are also going to look at your host and your OS. So we would use the -O and -V for the operating system version. And then we would get the port by looking at open ports. So if it is open, we want to be able to obtain that. And then this is going to give you the display for your port description. Now it is in a dictionary, so it's associated the key with the values. So we would see the type of ports that would be open. Then in addition to that, we wanted to print out some details about the operating system and the port. Okay, so this example is a parallel script that you would see when you're running Nmap or ZenMap, where you would be able to obtain open ports and operating system. That's your very simple scan. Any question regarding example 2? In the next one, we're gonna scan it asynchronously. And so here earlier, the author mentioned that we would use a function or a method, right? And we would call that to be able to obtain the result. As it would do it simultaneously, okay, we would have a range of port in order to use it to scan. So you would see that it's slightly different, where your port state here is going to contain your scan result, and then everything is in a list. And we would want to print out the port information. We also have to create an object, and in this one we want to make it asynchronous. So we define a class, it instantiate the object. Now the big area that's different, so instead of using your regular port scanner object, we're going to use port scanner async. That's the key, right? That makes it different. So as we use the module, if you're using this class, right, to instantiate the object, it's going to allow you to do it asynchronously. Whereas the other one, the simple port scanner class, that will be synchronous. Then in the next function, we have a scanning function, and we would have a loop, a while loop. While it is asynchronously scanning, right, we would want to also give it a wait time. And for those of you who took advanced Python, you saw how we would implement wait as a way that we can slice that time. So that way it would operate asynchronously. So here we would also have a wait of 5 seconds. And then the next function, we have the Nmap Scan async. We would try, right, to scan the port. And then we would do a callback using our callback result function or method. Then we call on scanning method that we defined in the prior section. In the exception, we're just going to handle the error if it's not reachable. Then in the main, we would parse the argument. We would add that so that way we can output as display. Okay, and then lastly, we call on the method. Okay, so that's what you see. It's slightly longer in that, you know, the details in how we would want to parse it. But the whole key point in this is I want to show you that when you're using, right, Nmap Scan async, that's going to be asynchronously. Let's cover a little bit more on the OS module and then we'll do the rest. There's only a couple more things I have to do for the assignment. So in finding operating system information and also using asynchronous, you can also use modules such as subprocess and OS. We talked about these earlier on. Now you can write the script in order to do this, or you can simply use Python shell again. So if we call on Python, we would be able to access its shell. We can import in the OS module. And we would create a variable called nmap command. And for that command, we would use st type of scan for nmap and then the target. Okay. So if you're using the command like this, we're simply going to pass it using the os.system. So using the system method, because we import in the OS, we would be able to plug in whatever that we declare in the nmap command, and it would use that as a parameter here. Okay, so that's another way that you can do this, right, using the OS module. Okay, you simply import that in through, you know, through Python shell, and then use the shell to be able to execute nmap. Okay, so let's talk about the next exercise. 9. So in this one, what I wanted to do was to give you some of the details that was included in the text, like what we've seen in the notes, how to use the OS module. So coming back here, and I'm already in my shell, I simply would do an import OS module to bring it in. And the next part after that, right, once I have access to shell and imported the OS, I simply would create a variable called nmap command. And then we would run that here. Okay. Not liking. Oh. Let me replace it and decode my symbol from Microsoft Word. Okay. So it should work. Just if you copy and paste it in, the quotation mark didn't translate. So we want to replace that and retype it. So after we put that in, charge me. Then what we're going to do next is we are going to use the command now. Okay. So we're going to use that. Okay. So when we use the system method, right? It's going to tell us 998 closed ports. Our port state is for service. We have open ports. Okay. So this is on my system. Yours is going to be slightly different depending on. So I have Tor socket that we did for Tor. That's open. Right. The 9050. And then I also have this open. Okay. So it only scanned my address. So the 127 is a loopback and it was done in this time. So it gives me the report there. So as you do that, you would see, right, the open ports, the closed ports on your own system. It might look like this or it's slightly different depending on what kind of services you have. Okay. Any question regarding 9? So that's how we're able to use OS module with Nmap in Python or Python shell to be able to scan a specific target, and in our case, our own system, a host. You can also use subprocess, and subprocess use popen. This is a way that it would be able to access the command for Nmap. Okay, so as we look at example 5 here, we have an object called process, and this is instantiated for popen. And we would simply put this into a list that it's going to be for Nmap, right? It's going to look at, this is the target, this is the option we're going to use. So for the subprocess, it's going to use std out and std error, and we can define that as type there. Okay. So when it communicates, if it's detecting any kind of error, right, it's going to be for std error. And for the std out, which is going to be our result, we want that decoded. Okay, because as the application, it is encoded. So in order to bring out the result, we have to decode it. Okay, so using a subprocess module, you can also use Nmap, but it is slightly different than the OS module or the python-nmap module in general. As the module is defined with different classes and different type of command. Now, Nmap is often used for vulnerability assessment. So you can scan, and it uses Nmap itself has a scripting engine. And that's done through Lua, okay, which is a language or a scripting language. You often see Lua being used for browser or other form of application. You can use different scripts in the Nmap itself, and some of you have seen this or done this before to scan for or look for vulnerability. Now, how do I find these scripts? You can go to the link that's provided there, which is if you go to nmap.org and then you go to NSC, which is for the Nmap scripting engine document and scripts, you will find the pre-made scripts that's here. Okay. So you can, it's alphabetized, so you can find a lot of the information. So in the case, there's Bitcoin, so you just click the link and you'll be able to see the script. Okay, so some of the script that we use, you will find them here as well. There are lots. And this works with Nmap specifically. So to find vulnerability, we can look for authentication. So we can execute available script for authentication. So when you use auth, that's for authentication. You can use the default, that's just your basic script. Discovery retrieves your target or victim information. It gives you more details than your basic. And we will see that in the next exercise. You can use script for external source. You can also use script that are intrusive. Now, if you want to check malware with a certain connection, you can use malware script. And then if you want it non-intrusive, you can use safe script. And vuln is just for vulnerability discovery. And then we have an all, which is the catch-all, where it would be all script for NSE, which takes longer. So to execute it in command line, you simply would do a sudo nmap like this. Specify the type of scan that you want. So normally we would use the SSV. And you can look for specific things like banner for that particular domain. Okay, so in this example, we simply is going to scan banner from scanme.nmap.org. If we want to do discovery, we would use, right, we would scan with nmap, and we just use the dash script here that will be telling it with the command that we are running a script, the type of script that we're using, discovery, and then the target, IP or domain. Now, you can scan for host key with SSH. Okay. And there are various options. So here we would scan for a host key that would be related to public key, or we can scan to enumerate the keys using SSH2. And it's slightly different, but ultimately we would have the target at the end. So the script that you're using, and this should be dash, the script that you're using is going to follow the option script, okay, and then your target. Now we can also do the same thing for FTP. So any of the script that you have on the page there, and if you want to run it against a specific target, you just need to specify the type of script. Okay. Any question? So now let's try it, right? Put it in applications. So number 10. We're going to scan for banner and discovery and other things. So we will start with using only the terminal, but this would only work if you have Nmap installed once again. Okay. Okay, so I'm going to go ahead and do an exit function here to come back to my terminal. And I'm going to run the banner script. And I'm going to scan my target, which is scanme.nmap.org. So it's going to take a few seconds, sometime longer, depending on the target and how we're connecting to the target. So here it tells me that it started the scan for the nmap.org. Okay, this is its public IP. There's the latency, which took 0.08 seconds. It has an IPv6. The not shown filter ports, it shows 997. We have port 22 open for SSH, and that will be for Ubuntu. Here's the SSH version that they're using. So through the version of the SSH, I can also identify some vulnerability with that particular version of the protocol. And now it's going to give you the banner here. And with the nping, it shows that 9929 TCP is open. And then your TCP wrap, this port is open. Okay, so Linux base, you would see that that will be Ubuntu. And that took 10.91 seconds for that scan. Any question? So when you run the scan for the banner, which is step A for number 10, right, you should be able to see some information about your banner. And if it's giving you, if it's doing any type of service. So in some case, you would see Apache or, depending on the type of servers it's here. So my banner information, it shows me SSH. Service detection. Okay, and the service information it tells me here. So that will be the Linux kernel. Then we move on to step D for 10. We're going to do discovery now for the same domain. And we want to see the difference between that and the banner. So back to our terminal, we would issue the command nmap, and we are going to use the script type discovery for the target. So it's going to go for a little bit, and it's going to give you some details. And in this one, you should be able to gather more information about that particular domain. right? Beyond what you would see with just a banner. So at first here, you would see that it's giving me the ASN. And it will give me more details. So let it go for a little bit. So now, so you would get, with the discovery, we have more, okay? And as it run that script, let me come all the way back up here. So we got the ASN information, and it also gives me my public IP for the target, latency information, IPv6 that's associated. It tells me that it's not scanned. Ports information, like what we seen with the banner, OpenSSH. We also get the banner information. Okay. But it's going to give us the host keys. So here you have some host keys information, RSA, DSA, and so on. In addition to that, sorry, it's so long, but let me come back. I just lost my place. Yeah. So here it also gives me, it enumerates the SSH. Okay. And then it shows me open ports, Apache, Ubuntu. So that's a web server. And then, so the discovery definitely give you more details as the output. And some of you have seen this when you run Nmap or if you learn about Nmap in the past. It also give me DNS information like A record, quadruple A records for IPv6. And then it runs who is. That's part of the actual script itself. So when you run discovery, expect that it is a little longer, and in comparison with the banner that we ran, right, it's 4 times longer as it gives you a lot more information. Okay, so after you scan it, you can describe the host latency, how many records of the DNS are discovered. And step G, it's simply, we got this from discovery as well, but what if we only want to run the script for the host keys? So coming back here, I want to clear that. Okay, so we are going to run just for the host keys. And unlike the discovery, it's only going to give you host keys information. So the same as what we've seen previously. Okay. So with that, you should be able to answer what type of SSH keys are displayed, and you don't have to put down all those key information, just the type, right? Like RSA, DSA, and so on. And this is why it's good for looking at vulnerability. Is beyond that, we would be able to really dig in the specifics, like host keys, version, the details that we can use to either reduce the risk from the existing vulnerability by fixing some of the areas, right? Or from an attacker standpoint, take advantage of it. Now, if we want to enumerate the keys, as in discovery, it does that as well. But if we want to only enumerate the keys, we can use the script. And sorry, this should be a dash, okay? Microsoft Word sometimes auto corrects me. But we would use SSH2 enum algos. Oh, it's copying the A. So, okay. So, so with that, I just need a screenshot. But we saw this before when we did the discovery. It includes that. You also have open ports information, latency information, service information, and so on. It says failed to resolve. Oh, let me see. I'm getting, it's not. Let me fix the dashes. See if it's able to do that. I'm pretty sure it's the issue. So make sure we use a double dash in front of the script. Otherwise, it's not going to execute the rest. There it is. It should be like that. Okay. So when you see this, you would see it tells you more details on the SSH enumeration. Okay. The algorithm. So we see Duffy-Hellman, curve. So the type of encryption, AES, and so on. HMAC, UMAC. And that took, for me, 11 seconds. Okay, so you should see something like this. And as you do that, we would do a screenshot for the output. And in the notes, also talk about how we can use script for FTP. And we would use FTP anon. And in this one, we actually want to test an FTP site. So we would use the ftp.be.dbn. Okay, so as we scan the FTP site, right, using the script FTP anon, we would have the typical information. It shows you your DNS record for this. The important part with this is when you're running anon with FTP, that just simply let you evaluate if that FTP site has anonymous login capability. So it tells me that it is allowed. And the FTP code for that will be 230. If it is not allowed, it would show that here as well, but not this way. And it also shows, right, the content for the FTP. as pertain to permission for the directories. And we touched on FTP last week. So using this script, it's simply assess, right? Anonymous login capability and the open ports. And as we know, the FTP uses port 21 in general, right? And then this. So when you complete that, what you would have is you would be able to answer L. Does it allow anonymous login, right? What is the code? And as we see that, we would see that here. Any question? So through this chapter, you're able to experiment with Nmap, with script, right? With modules where you can use Python or you can use the script directly, the pre-made script directly in Linux. And and this is just a tool that you can use to assess vulnerability on your networks or on your systems. Now, if you want to do Python, example 6, right, shows you options on how you can use argparse and nmap module to be able to write the script. Okay, but use the existing script, which is for the Anon NSE, so you can bring that in through nmap module and then be able to use that script. Okay, so that's another way that you can do this. Okay, and then we can use our command to be able to run that asynchronously. Now, on this example, it also shows you how to check for backdoor. Okay. And so it is a little bit more extended than what we have used in command line. So example 6 is also a good option for anonymous login check, but it also can be used as there's a section for backdoor evaluation. And when after you write the script in Python, right, you just have to specify your target host as it is not coded within. So the way that you run it in command line is you do a Python 3, your script name, and then -- right, and then your target host information. Any question? Okay. So through the assignment, we're able to use Nmap in various ways. And I didn't go over the graphical user interface, but you can also download and run it in GUI. The whole point in this is to be able to use Python script and pre-made script with command line. Now, if you downloaded the source code for the book, you can also check out their other scripts. Let me go to Tani here. Okay. And so I did include some of this in your notes, but as you look at the source code, let me go and show you. Okay. You can use the async FTP. We touch on CSV. There's, so most of the stuff we have included in our notes. However, if they're kind of similar, I don't include it. So you can also check out other example that the author provides. Okay. So we are going to meet on Wednesday to do our lab, but next week is spring break for our CCD, the 10th through the 17th. Okay, so hopefully if if you wrap up everything by this week, you don't have any homework going into the spring break. I will make sure that I can get caught up with all your grades this week. Okay. Now, and then we will resume with chapter 9 when we come back. I originally planned to include 9, but 8 is, a little lengthy. So I was afraid that you might not be able to absorb everything. So we will address 9 when we come back, where we would do some vulnerability scanning using OpenVSA, and then looking at application like Nessus for compliance and vulnerability assessment. Okay, but Nmap is quite a good tool that it is versatile with scripting and using it at command line level as well. Okay, any question regarding your assignment for today or the chapter? Okay, so with that, I will go ahead and stop the recording.